some activities called colored loops, but this funky picture is a tribute to its old name, or its initial name, which was stirring paint. So this is a funky stirred paint picture. So colored loops, stirring paint. I thought I'd give a little bit of history. This puzzle was invented by Gord, who you all know from last month, I think. And a couple of interns, Jade and Helenka, in 2020. And in the first deployment of this puzzle, JRMF called it colored loops. And there are slides, apps, and notes, and I'll give the links, or those are on the website. And they added one-dimensional rings rather than, it was initially a two-dimensional puzzle to lower the floor. The JRMF activity has three sections: the ring puzzles, some modularity puzzles called More Rings, which Skana and I developed, and the 2D grid puzzles. So that was phase one, and that's all available on JRMF website. The phase two, I really like these puzzles, but I didn't agree with some decisions. I think grid puzzles 3, 8, and 9 are less than desirable. 3 is too hard, 8 and 9 are ambiguous. So I built a platform on Polypad, which everybody's used by now, to play the puzzles, teach puzzles, and create grid puzzles. And so far we have 45 puzzles of varying difficulty set by my students, elementary and middle school kids, Daniel, Peter, who are facilitators today, and by me, but mostly by Gord. And he's very supportive of this platform. And the reason I really did this is because I enforce uniqueness. I think logic puzzles should be unique. Everybody doesn't agree with that, but that's how I feel. And what are we trying to learn? Like most logic puzzles, incremental deductive reasoning. What's the smallest step you can make, and how do you build on that? Parity and modularity, creativity and puzzle design, because it's really fun for kids to design puzzles and then learn how to make sure they're good puzzles. There's a greatest common divisor aspect, circular reasoning, which I'm joking a little bit because the rings are circles, and two-dimensional reasoning. And there are some links that we'll make available to everybody. All right. So colored loops, this is the phase one stuff. The object is, you have a ring of arrows, and you want to complete each puzzle by coloring the numbers and the arrows without breaking any of the rules. So they start out gray, some of them, and you can add colors or numbers. An arrow's number tells you how far to jump clockwise when you land on it. So let's see. I should be able to annotate myself. So this 2, we jump 2 steps. Or I could even better, we jump 1, 2. And this 1, we jump 1 step. And this 2, we jump 2 steps. And we make a loop of green. So rule 2, when you jump, the arrow you land on must be the same color as the arrow you jumped from. And rule 3, all the arrows that are a given color, like all the blues, need to be in a single loop. You can't have 2 blue loops. So can anybody tell me which of these, A, B, C, D, which follow the rules and which ones don't? Perhaps in the chat. Or aloud is fine.
I think A is the only one that follows the rules.
All right, so what is B's problem? Stephanie?
The number 1.
Yeah, the green 1 points to a blue 2, so that's no good. Does anybody care to explain the problem with C? Let's study it. 3 it goes to here, 2 goes to here. Then 2 goes to here, here, and here. So we have 2 blue loops. All the blue ones have to be in a single loop. And let's see. 1 goes to 2, 2 goes to here, and to here. And this one goes to here. That one's okay. It just goes around twice. Unless I made a mistake here. I think that's okay. All right. Sorry about that. So if this were the puzzle, the 3 of the arrows are completely specified. They have a color and a number. This one has a number but not a color. This one is a color but not a number. But we can see that this 2 points to green, so it has to be green. And this is pointed to by a blue 2. So I'm sorry, the only place it can go is over here. So, oops. And that's the warm up. Now we get into the puzzles which are shown in the app. So I'm going to show you a little bit how the app works, and then we'll go into breakout rooms. Oops. So in the app, this is the same puzzle we saw before. 1, 2 is green, so you put green on this arrow. And 1, 2, 3, this has to go over there. So we add a 3 to this arrow. Then check. Gold star. All right, that's the intro. We have 5 breakout rooms. Welcome back, everyone. I hope everybody enjoyed this activity. I don't think in my initial discussion, I expressed how much I love this activity, but I think it's fantastic. What I like to do, no, that must be referred to closing rooms. All right.
We were just in the middle of a really great observation. It's okay.
Oh, well, finish it. So what was the observation?
Sure. Okay. Is that okay for me to share this, Steve? Did other rooms get to look at puzzle 21, 22, like those ones? Where they all had the same number?
Yes.
So
Okay.
hold on to Ashmita, hold on just a
Sure.
second.
Yep.
What I was going to do is ask everybody to put in chat something you learned, some strategy, some observation, and you can add your observation if that's appropriate, or describe it as to the group afterwards, Ashmita. So please type into the chat something you thought was interesting about this puzzle, some technique you learned, you figured out, or you can just write about how much you love the puzzle like I do. So getting to know the patterns was too much fun. There seemed to be a set of patterns that was developing that looked like it might deal with primes, composites, and factors. Connecting using arrows and marking using colors. That's great. This activity can be connected to patterns and factors. When it gets to the higher level, thinking gets complicated. Ooh, lots of thinking. Use of color and number matching. Interesting, fun. Making connections. Ashmita, I cut you off. Would you like to continue?
That's okay. We were just, I think maybe were like one step behind other people with our observations, but we had a really wonderful, we were just finishing up this puzzle in my room. And there was a really wonderful observation that, let me press check so we get our star saves, that when we had the puzzle with 5 arrows and 2s, we had 1 color. And when we had 6 arrows and 2s, we had 2 colors. And then we needed 3 for this arrows with 3, and some people had said in the chat about primes and composites. and factors. And that's really what the relationship is that I didn't get to do in my room, is that when we have threes, kind of they go in pairs because 6 is 3 times 2. And so then we needed 3 for each of my arrows, or sorry, I had 3 different colored arrows because I could put each pair into groups of 6s, and that's where some greatest common divisors come in, which is really exciting to me because I actually taught my university students about GCDs like yesterday. So that's really fun for me to talk about. So yeah, then you can make predictions about what will happen with other ones. Like how many colors will you need to color? I had skipped this one in my room, probably other rooms looked at it, of how many colors I will need to color in 5 arrows with 3. So I'll leave people to think about that if they haven't already. Thanks for letting me infiltrate that for a second, Steve.
Oh, no, absolutely. And Nephi says it's hard to do if you don't actually have a tool like a pencil to write things down, and brains exploded. I'd like to, visual learners will probably appreciate this activity. I hope so. I hope so. I think that there's a lot of depth in this activity. There's technique about multiples in the early puzzles, GCD and the sequence of puzzles with all the same number, going forwards, going backwards, and the learning about essentially graphs and how they're connected. So, and unless somebody else has some other observations, I think we're going to close this section, but let's,
Can I make a comment?
please.
I think sometimes we forget how important looking at the composites and the primes helps even in the higher level math. So I've been doing factoring of polynomials with both my sophomores and juniors for most of the year. And some of them, we use the box method for a lot of them because it helps them visually organize their information. But a lot of times they get caught up taking the calculator out to try to find all the factors. So for some of the students who are struggling with being able to recognize things, I started showing them how to do prime factorization of larger numbers and then combining those prime factors to come up with the factors that make sense, instead of just randomly putting numbers into the calculator to see if they're a factor. And so I think that making sure that we know that our students, when they're young, know the difference between prime and composite numbers and know what factors are. It carries on, even though we don't recognize sometimes that it does.
Thanks, Stephanie. I'm a big fan of prime numbers. Skana?
I'm a fan of composite number. No, I was just going to say that I think that is a super important point. And in fact, I often tell parents of my students, the most important thing to learn in math in the entire elementary school is how to do a prime factorization of a number. If you can take a number and split it into its parts and understand how they're put together, you really understand that number and can work with it. And then, like you said, you can apply that to polynomials and everything. I think I totally agree with you. Extremely important.